Hey everybody, welcome to our online class. Last time we talked about electric fields, and this time we're going to extend that discussion to multiple charge distributions and continuous charge distributions. Let's recap really quick what we covered last time. Let's say you have two charges, Q1 and Q2. Let's say they're positive, and there's some distance between them, R. These are going to feel a force. If they're like charges, they're going to feel a force pushing outwards. And this one's going to feel an equal and opposite force. And the strength of that force is given by Coulombs Law. The electrostatic constant K times the magnitude of each charge over the distance between them squared. And this force acts in the radial direction. If we've got like charges, then R hat points outwards. The positive R hat direction is outwards. If they are opposite charges, then you have the negative R hat direction, which is inwards. Physicists were very upset by the idea that one charge could push on another one without knowing that it's there. So we created this concept of electric field. So Q2 creates an electric field, and since Q2 is positive, that electric field points outwards. And it gets smaller and smaller the further you are away from the charge. So Q2 modifies space, and Q1 comes in and it feels that modified space. It feels the electric field that Q2 has created. So if you're Q1, you feel a force, and it's related to these things. So this thing right here, that's the electric field of a point charge. So Q2 is creating an electric field. You bring in Q1, it interacts with that field and feels a force. The same goes the other way. Q2 doesn't know that Q1 is there. All that Q2 knows is that it's kind of weird here, and it feels a force, because Q1 makes an electric field, and Q2 interacts with that field. So that's the basics that we got last time. Let's move on to situations where you got multiple charges.